So this tutorial is about how to determine sex linkage in a pedigree, or how to identify sex linkage in a pedigree. So linkage is simply a term that we use to indicate the location of a gene. So genes are linked to whatever chromosome that they are located on. If a gene is linked to an autosome, then we say it's autosomal. It means it's located on that autosome. So you could say that a gene is linked to, chromosome 10, and that just means its location is on chromosome 10. If a gene therefore is linked to the X or Y chromosome, the so-called sex chromosomes, then that means that the gene is located on that chromosome. So when we say a gene or trait is autosomal or sex-linked, we're really providing information about the location of the gene in the genome. Those are words that indicate the location of the gene. Of course, autosomal is a pretty broad term. In humans, there are 22 autosomes, and so autosomal would mean that the gene is located on one of those autosomes. Now, sex-linked technically indicates that the gene is located on one of the sex chromosomes, but because there are so few genes on the Y chromosome, when we say sex-linked, usually what's being referred to is actually X-linked. Typically, if somebody is talking about a Y-linked gene, they'll call it Y-linked. So you're pretty safe to assume that sex-linked means X-linked. And for me, in this class, we'll be only talking about X-linked genes, since it's an introductory class. Now think about this. There are a lot more autosomes, 22 autosomes, than sex chromosomes. And we already said there's very few genes on the Y chromosome. So if you think about the X chromosome as a pretty average-sized chromosome, and it has kind of an average number of genes, then if you think about the distribution of genes, 23,000, let's say, genes are spread out on the different chromosomes, then most of those genes are distributed onto the autosomes, and only some of them are on the X chromosome. So as a rule, most genes are going to have an autosomal location. That's just going to be the way it works out, because most of the chromosomes are autosomes. So as a rule, you're safe to assume that a gene is autosomal. When you're looking at a pedigree, that's basically your default belief, is that the gene is autosomal, unless there is an unusual pattern on the pedigree that forces you or that compels you to consider X linkage. So what is this unusual pattern that I'm referring to? If the affected, meaning the shaded individuals, are all males, or in a very large pedigree almost all males, then in this case only, you have the permission to consider the possibility of X linkage.